Hey guys, in this video we are talking about properties of functions. So how to tell when something is a polynomial function and how to tell when something isn't a polynomial function. So something that is not a polynomial function will have roots associated with the variables. So something like the cubed root of x, not a polynomial function. Something like the square root of x, not a polynomial function. If the exponent on a variable is negative, it's also not classified as a polynomial function. 1 over x, that's equivalent to x to the negative 1, not a polynomial function. Something like negative 1 over the square root of x, that doesn't say x. Whenever you see the square root of x on the bottom, that's a fraction exponent. It's also a negative exponent. And you can't have any coefficient that is not a real number. So all your coefficients have to be not imaginary. They have to be real numbers. So for example, if you had like 6x plus the square root of x plus 4, you were asked, is that a polynomial function? No, because the square root of x makes it disqualified from being a polynomial function. So polynomial functions they follow the pattern, and they need to follow the pattern. F of x equals some number times x to a number that's not negative and not a fraction up here, plus a to the n minus 1 of x to the n minus 1, etc. The next term will be plus a to the n minus 2 to the power of x to the power of n minus 2. The a's are the coefficients. This first one is called the leading coefficient. If it was a of 0, that would be your constant term. N is the degree of a polynomial. So if you had, let's say, x squared, the 2 would be the n, and that would be a degree 2 polynomial. So do I have any questions for you guys? Yeah, let's talk about some words first. There are different types of polynomials. You've got monomials, binomials, and trinomials. And those are arranged by not the degrees, not the value of the highest power, but by the number of terms. Something like x would be a monomial. The graph of that would be something like that. A binomial would have two terms, like x plus 6. X is one term, 6 is another term. They're separated by either the addition sign or the subtraction sign. If it's the multiply or the divide sign, that does not separate terms. If this had been x times 6, it's one term. X divided by 6, it's one term. X minus 6 would be two terms. X plus 6 would be two terms. That would be some graph like that. X squared plus x plus 6, something like that. It has 1, 2, 3 terms, 3 different parts separated by equal signs. And that would just be some parabola-ish type thing. Okay, so degree and telling the difference between the number of terms, which would be monomial, binomial, and trinomial, they are different. If you have a constant, like x to the power of 0, that equals 1. 1 is a constant. It's just a number. It's not a variable. If you had something that's linear, that means the largest coefficient you see, so not the largest coefficient, the largest exponent on your variable is 1. If I had x plus 6, I only have one x. The highest power on x has to be 1. A quadratic would be an example like this. X squared plus 6, or x squared plus x plus 4. 2 is the value of the largest exponent. If you had a cube, something cubic, 3 would be the value of the highest exponent. So in this example, x cubed plus x squared plus x plus 1, 3 is the exponent of highest value. A quadratic, I could do the same question and just add x to the power of 4 in front of it. So in terms of coefficients, they can really be quite a large variety of different numbers. So I'll give you some examples. Okay, so you could have 3x squared plus 2. You could have a whole number as a coefficient. You could have the square root of 3x squared plus 2. You can take the square root of a whole number. You could also have a fraction. It could have been 1 over the square root of 3, and that still makes it a polynomial function. So where we go from here is dividing polynomials by other polynomials. So I'm going to end this video and do an example where you will divide, let's say, a trinomial by a monomial or by a binomial, and I'll show you how that's done.